as usual. And of course, as just like all the other weeks, I will make the recordings available to everybody. And if you remember from our last session that we had started working on this part over here, as you see on the screen. And we had done a face milling operation on top. Okay, we did some profiles around the part. And we also worked on this pocket here in the middle. And what I asked everyone to do was I gave everyone homework, basically, is to, now that we knew the profile and pocket operation of face milling, I had asked everyone to go back in these times and continue on with this part, working on these pockets that we have over here, these areas over here. No, it's all these areas that need to be worked on as far as pockets and profiles, and to see how far you can get. Does anybody have any questions on this? Again, your microphones are they're self-muted, so you can unmute yourself and ask me questions at any time. Okay. Does anyone hear me? Okay. Marv, okay, I see you hear me.
I hear you, yes.
Okay, excellent. Okay. Did you have a chance by any way to go over the part and continue with it?
No, I'm so sorry. I have not had the opportunity to do it.
Okay, everyone's busy with their things. I understand that. Okay, so what I have done already here is I came back and I already machined the rest of these areas over here. Okay, so for example, we had this pocket over here that we started out with, and we had this pocket over, and we finished it off with this operation over here. Okay, and then also I did actually 3 operations here to finish it off. What did we do? That's what we did last time. Now, what I wanted to do is I wanted to continue with the operations for the rest of these areas. Now I'm going to take what I've done already over here up until this point. I'll just click on hold shift on my keyboard. I'm choosing all of these operations. And I want to do something called suppress. If I right click on it, I can do what we call suppress. Suppress, what it actually does, you'll see now those operations are there, but they're as if they are not there. So as if I did not do anything yet. So now what I'd like to do is, now that I have these operations, say I have this one where I did the roughing, and this one here where I did a finish on the floor and the walls over there. What I'd like to do is I'd like to do the same thing on, say, these areas over here as well. Okay? How do I do that? I can go ahead and create a new operation. Okay, we saw how we created a new operation. Or I can do something else. Let me uncheck this so we don't see what's going on over there. I can highlight that operation, hold my control button, and click on that operation where I have these two highlighted. And I want to have them apply to these areas here as well. Okay? How do I do that? Now that these two are highlighted, I can go onto one of them, hold my mouse button down, and drag it onto the surface. Now, I want it not just on this surface, I want it on this surface and this surface as well. So when I come to drag it on this surface, before I let go of my mouse, I'm going to be holding my control button. Let go of my mouse now. I'm still holding my control button, and I'm clicking on every one of those surfaces. Now I'm going to let go. And what you see here is that two new operations were created with the exact same technology that I used in these two operations. Okay, so this is a quick way, as you saw how quick it was, to create new operations. If, for example, I also wanted to do the same thing for over here, I can take that pocket, those two operations, and again, drag it to this surface over here. And as you see, it also did that. Now, I took these two operations, but in essence, I can really take also these operations that I created before. And I can take these operations and I can continue with them as well. I can say, let's click, drag it to over here. I want to work on that area. Okay, you see how quickly I can go ahead and update operation, do it on here. Okay, so all of these operations, I can just go ahead and work on them and just drag it to there instead of actually creating new operations each time. Okay, and this I can do for every single one of these areas. Now you'll also note, let me just get rid of all those check marks. I have a step over here, this area over here. Now, it may seem like a simple profile, which it actually really is, just a simple profile operation. But since this is a surface, I can actually treat this just like a pocket operation. Why is that? Because I have my geometry, which is the entire floor over here, and these edges are open edges. Okay, so let's say I take these two operations. Okay, I'll take these two that I created before. Okay, these two over here. Or I can actually say these are over here as well. Why am I going all the way all over the place? Okay, I'm going to take these two operations. Okay, why these two? We have a rough and finish. I can take them, drag it to that surface. I'm going to hold my control button, then click onto this surface as well. Continue around this thing, this surface, even this surface over here, this one over here as well. Every single one of these surfaces I can click on. And when I'm done, just let go of my control button. And as you can see, all of them are created. So basically, in just a few moments, I actually created all the operations that I really needed. Wait, there's one more. Almost forgot about it. Let's not forget about these two pockets over here. So again, I can take these operations here, drag it to this one and this one here. And we have our pockets for that area as well. Now, sometimes you may have something like this pop up. Why is that? Okay. Let me just click on OK. And get rid of these two operations over here, sorry. This and this. I want to get to a specific operation. Just a second, which one do I want to get to? Not that one. Ah, yes, I want to get to this operation here. Okay. So what we have here is as follows. You'll note that this type of pocket over here is a closed pocket. There are no open edges. So in order for it to plunge into this pocket, it's using a helical ramping to get into that pocket. Okay. Now, since I used a specific tool to go into here, if I were to use this ramping angle or this diameter that I have over here, that will not fit into this area. Let me just open up that operation and let me show you what I'm talking about exactly. Okay, if I go to my link area, you'll note that we have what we call ramping, and it's default at helical. And it's going at a 5-degree angle at a radius of 5.88, which is based just under the radius of that particular tool. This tool is, if I believe it's correctly, it's a 12-millimeter end mill. Okay. Now, that's fine for over here, but it's not necessarily good for over here because this is a smaller pocket over here. So what that message said was, okay, it's just correcting itself that it will use the largest possible radius for this area over here. Okay. So now that I've done this entire pocket, I want to continue on now, and let's talk a little bit about the drilling operations. We did face milling, we did pocket profiles already, we did pockets, and now we want to deal with drilling operations. Okay, so let me just get rid of what we did just now. I want to delete all of that. Just click on delete, and I can delete that. I'm going to take what I have up until here. I'm going to unsuppress. Okay, that's already stuff that I've done before. And as you can see, everything is active again. So just to run the simulation before I do this, to see exactly what I've done up until this point, on top over here, I'm standing on operations right now. So on top, when I click on simulate, it's going to simulate the entire part. I'm going to do solid verify simulation and just play everything. And as you can see, everything over here has been machined out. So what's left to be done over here are the holes. Okay, so doing the holes we call drilling, as we all know. So I'd like to start, and I actually just want to work on right now these particular holes over here. Okay, we have here some tapped holes. I'll show you first the long way of doing it, and then I'll show you the quick way of doing it afterwards. Okay, so I want to go into my drilling operation. On top over here, we have drilling. Just click on it. Drilling operations, just like any other operation, needs to have a geometry defined. Now, a drilling operation, a drill geometry, as opposed to the other geometries, is not a boundary, but it's a point. What point do I actually want to go drill into the part? So now what I do on create geometry, we have drill selection. Okay. Right now, we have different modes for creating a drill. Let me just open that up. Okay, this select and unselect. We have select centers by. How are we selecting the centers? Okay. Our default is multi-position. Multi-position basically means picking a face. Okay, so let's say I would click on this face over here. You'll note that it created the geometry for, every single hole that is on this face, including holes that I may not want. Okay, as you see, it took these holes here, but it also took these counterbore holes. I don't want the counterbore holes. Okay, so let me go back here, I can right click on one of them and say delete all. So in other words, I need some kind of filter that's going to say, I only want a specific diameter of holes. Now, before I do that, let me just show you one more option over here. I could also go, instead of clicking on the face, I can also go ahead and just click on each hole individually. If I click on the inside of each hole, it creates it just for that particular hole. So that's good if I want to do individual holes. Now I can again do it for every single one of these holes over here. Okay, but I don't want to do it that way. So I'm going to again delete all. Okay. What else can I do? I can use what I said. I mentioned the word before of filters. So let me open up my filter over here. Right now you see it's marked at all circles. I want you to take every single circle that on that face that I'm going to click on. And that's exactly what happened. But I don't want that. So we have another option here by radius. If I know the radius, I can write in the radius over here. If I don't know the radius, I can click on by radius. This is actually a button over here. If I click on it, let's zoom in here. I'm going to click on the very top over here, the radius that's actually touching this surface. And I'll accept it. And now you can see that it automatically filled that field for me. So all I have to do now is click on the surface. When I click on the surface, it'll only take the holes that are on that surface and that have that radius. Okay, that's all I needed to do. I'll accept that. By the way, before I accept it, another point that's always good to do. You see where it says here name? It says drill. This is actually going to show me the name of in my operation, my name of my operation as well. It's going to use what's written over here. Now I can have 500 drilling operations. How am I going to tell them apart? Okay, so at the name, I can actually fill in what name I want over here. So say I'm going to put in, I believe this is M6. I'm just going to write M6. I may be wrong. I just don't remember exactly. Could be M6 or M5. I just don't remember exactly. Okay, I'm going to accept that. Okay. That's the name of my drilling operation, geometry. The tool that I'd like to use is a spot drill. So I'm going to create a new drill, new tool, sorry. And over here we have a spot drill. I'm going to just leave it. Now, I don't want a 6 millimeter. I want a 8 millimeter spot drill. Okay? Why do I want that? Because I also want that my spot that I'm going to have over here create the chamfer that I need for that particular hole. Okay, so I need a 8 millimeter spot drill. Okay, so I'll accept that. My levels. There's something here called upper level, which is user defined. And we also have by updated stock, according to where the stock is at that point. Right now, I'm just going to use user defined. Okay? We'll get into that at a different point. My upper level, if I put the focus inside here, I can just click on that top surface. And you see it's going to start from -10. Now, my drill depth at this point, how deep do I want to go from -10? Well, what I want to do is, let me see if I can do this this way. Hold on a second. I'm going to Let me see if I can do this correctly here. I once knew how to do this. I want to draw a little bit. I'll do it here. And I'm going to create a file. Just a new image. Okay. Okay, let me just enlarge it. Okay. Now, what I'd like to do is as follows. Okay, let me just get a drawing aligned. This here is my surface. Oops, my mistake. I want to make it a little thinner. Okay, let me get rid of that one. Delete. Okay, I want to have it a little thinner. Okay. Okay, this here is my surface. This here representing my hole. I want my tool, which has this angle here. Okay. To go down until this diameter of the tool hits my upper level over here. Okay, that's what I would like to have it do. Maybe even just a little more if I want to have it to leave a little chamfer on it. Okay, that's my goal in this particular case. Okay, so how do I do that? First of all, you'll note that my drill depth is set as 15. I'm going to set it that I actually wanted to go 0. In other words, I wanted to actually go just to that surface, but I want to have a particular diameter value. What diameter value do I want to have? Remember, whatever this value is over here, whatever the value of that diameter is, that's the value I want it to go down to. So, if I were to click on this area over here, let me just zoom in. I'm going to click on this diameter over here. Okay, it's not picking it up. Hold on, maybe I lost the focus. There we go. Okay, if that doesn't always work, we have what they call diameter value. Click on that. And you can see it's going to go to 6.05 diameter. Okay, that's all I need. Next, technology. The sorting, basically, if I were to show the sorted, and we'll go to the top view of the part, you see it's actually going to work in this fashion. Okay, going around this way. Why is it going this way? One, because that's in this particular case, that's the way this feature was built. Okay, so it's taking all of these holes. That was the order that these holes are built. Okay, we'll talk about advanced sorting. The advanced option at a different point. Okay. What else? What else do we have here? Drill cycle type. And of course, this is depending on the type of machine that you're working on. You have the cycles for that machine. Okay. I particularly, when I'm doing a spot drill, I like using G82. Okay, but that's my personal preference. The reason why I do that is because I like to have a little bit of a delay when it gets to the bottom. Okay, to make sure we get a full spin of the tool. How much of a delay? Not really much. Where do I set the amount of delay? If I go further down here, we have the data. Click on data. How much is my dwell time? For me, it's enough, 0.5. Okay. That's all I really have to do at this point. Save and calculate. Let's run our simulation. And let's see what actually happens here. We'll do this one step at a time, and I'm going to do this also at Solid Verify. You can see our tool is going to go down. Right now, it's at -20, it's clearance level. Now it's at the level of -8, safety distance between the 10 millimeters. And my next step, it's going down to 13.02. Okay, this is a 90-degree spot drill. So it knows how to calculate automatically the depth that it needs. Goes back up. And I just did it now until ran all of them now. So that's exactly what happened. Okay. Okay, so I have my first operation. My next operation, I want to use now the drill. Okay. The drill that I'd like to use would be for an M6, it's going to be a 5 millimeter drill in this particular case. Okay. So instead of creating a new operation, I'm going to go over here and do what they call save and copy. It copied that operation, made a new one, and now it's open to that operation. So now what do I have to do? I have to change my tool, and I'm going to create a new tool. This time I'm going to use a regular drill that is 5 millimeters in diameter, standard 118-degree angle. Okay. Don't forget you have your tool data, just mentioning that. Now my levels, let me see my part over here. This is a through hole. So what I'm going to do is my depth is going to be to the very bottom of the part. Okay. And I want the full diameter of the drill to go to the bottom. In other words, the full diameter is going here. In other words, actually going to go a little bit deeper to make sure the tip goes out. Now, I know a lot of people don't like to work to the exact to the exact depth of the part over here. They like to go a little further than that. So we have over here what we call delta. I'm going to go another -0.3 millimeters. Okay? Everyone can do whatever they want. Okay. Technology. Now over here, I'm not going to use G82. I like to use G83. Okay, for pecking. And in my data, my step down is what I want in this particular case. So I'm going to step down every 3 millimeters and click on OK. Save and calculate. Again, we'll run our simulation. This time I'm going to use the regular HostCAD simulation. And as you can see, my tool is going to go down. Sorry, I'm going to do it again. My mistake. And you see it's pecking its way down. Okay? And then going back up to the clearance level. All the way through the end. Okay. Now you've noticed though that it's going up to its clearance level. What if I don't want to do that? What do I mean? What do I mean by I don't want to do that? I only want to go up maybe to its let's see what else I can do here. Not clearance level, but safety distance above the upper level. Let's try that now. Okay. There was no change. Why? Okay. Let's go back over here. I think I mentioned this just before. If I go into my levels, I use what they call upper level -10, user defined. I'm going to make a little change in this part. I'm going to say user defined. Instead of user defined, I'm going to do by updated stock. The reason why I'm doing that is because I don't want to define my upper level. I want to look at where my actual stock is. Okay? So if I've machined this pocket out already, it'll start from this area over here. If for some reason I decided I first want to do my drilling operations and then drill out the pocket, so my stock is really all the way up on top over here, it'll start from the top. Let me just do save and calculate. At this point, it looks exactly the way it did before, no change. Okay? However, if I use this, that means we're recognizing the stock. When I'm recognizing the stock in my technology area, I have something here, links between. I can use something called shortest distance. If I were to use shortest distance, save and calculate, take a look what's happening now. Instead of going up, it's staying actually just 2 millimeters above the actual hole, and then moving towards each hole. So there's a lot less waste going all the way up to the part. Let's take a look at the simulation. Solid verify. Oops, I did a little bit too quick. It's doing its pecking operation, then going to the next one without going all the way up. Okay. Great. Next. What do I want to continue on doing? I still have to do my tapping operation. Okay. Let me get rid of these over here. These are tapped holes. So I want to go down and continue with my tapped holes. So again, save and copy like I did before. I have all the information I had before. I'm going to change my tool. This time, I'm going to use a tap. Okay? Note when I'm using a tap, I have different options over here. For example, I can use thread per inch. Okay? Pitch per inch, or as we use with the metric, pitch per millimeter. Okay? I'm going to use this. The pitch, I'm going to leave it exactly the way it is, actually, because this is an M6, 6 by 1. Okay, that's our default, by the way. Tip diameter is what the diameter is at the bottom. I'm just going to do select the tool. The levels, okay, in this particular case, I want to have just the cutter tip to go to a specific depth. Now, I don't know exactly what the depth is because this is, I don't have the blueprints in front of me. So I'm just going to guess it's somewhere around there. Okay, about 23 millimeters. I'll probably have to go back and look at it later on. Now, if I go to my technology, you'll note that it automatically changed to my tapping cycle. Because once I choose a tapping drill, a tap itself, that's all it can do, just your tapping cycles. If I go into drill cycle type, you'll see that is all that is available. Okay? Okay. Save and calculate. And we have our operation over there as well. Simulate that. Solid verify. Okay, nothing was done over there. Probably the reason for that is, okay, I'm going to do up, I'm going to get rid of this over here. User defined. I'm going to do from over here, just for that. And my drill depth is going to be, oops, sorry. Here we go.
Sidney, it's Yossi. I think that you need to change the delta if it's right, if I remember right. Because the delta here is minus 0.3.
Right.
So,
right. I
and
noticed that also. Thank you.
Okay.
Thank you. Okay. I'm going to do to that depth over there. I'm just going to put here 0. Okay. Save and calculate. And now we have what we need, I believe. Yes. Okay.
Sorry, easier, it's Yossi again. I think that you need to make it in plus because the thread is not till the end. If I look, I don't know.
What? I'm sorry?
The depth of the thread is not the depth of the thread is not till the end of the hole.
That is true.
So we need to get it in plus, the delta in plus, not in minus, right? Not 0.
In this particular, I didn't hit the bottom of the part. You're right. If I would have done this, okay,
yeah,
then I would have had to do here, let's see, 3 millimeters.
Okay. Yeah, exactly. This is what I wanted to see. Okay.
Okay, I could have done that as well. And that's a very good point. Instead of me guessing. Okay. But after I do my next step, you're going to see that everything I did over here, I really didn't have to do it. And you'll see why in a minute. Okay. Okay. The reason why I'm showing you all of this, because it's important to know what is actually inside the operations. Okay. Okay. Now, I said there's a quick way of doing this. Let me take what I have over here. I'm going to, again, suppress it. Remember what I said before about suppressing. Okay. These particular holes that we have over here, including these over here, they were all created inside SolidWorks. And in this particular case, they were all created using SolidWorks Hole Wizard. If I were to go to the part itself and just open it, okay? Just opening the part for a moment. I'm going to click on one of these holes. You see, it was created by Hole Wizard of SolidWorks. If I were to right click on it and just go to edit for a moment, edit feature, you can see all of the information that is over here. M6 by 1, the end condition of the tap is blind, okay? Whatever information that I have over here. If there's a countersink at the very top of the hole, everything, all this information is here already when I created the part. Okay. The same thing, by the way, for these holes over here, which is an M3, and this over here, which is a counterbore for an M5. Okay. So what's the quick way of doing it? We have here on top something called Hole Wizard process. Okay? It's a process that we built, okay, that deals with everything that was done within SolidWorks Hole Wizard. So if I were to click on that and say click on this hole over here, the program will crash. I hate when that happens to me. That's because I'm working in a build that I just took today. My apologies. I'm just going to do this for now. Close the program. I hope this is not affecting everything else. Okay, so just a moment. We go to my task manager, go to here. Okay, and go over here and end my process tree. Okay, I'm going to restart the program. Get this out of the way. By the way, photography, that's also one of my hobbies. Okay, rerun the program. It's actually good that it crashed because when I open up the part again, I want to point something out. When we're working in a SolidCAM project, which we were working up until now, we have what we call Prz file. A Prz file is a compressed file of our SolidCAM project, and that's what we're working on. When we're working on a Prz file, I'm going to go browse to go to my recent parts. I can go with that over here as well. Browse. Okay, it actually creates a temporary. It holds the original file in a temporary folder and opens up a regular working file on the computer. Now, if it crashes like it just did, when I open the file, it's going to ask me, do I want to continue with my temporary folder version, which is what I was working on, or go back to the original? If I go back to my original, everything I just did will be deleted. Or not be deleted, but it'll go to whatever was not done in this area over here. If I go back to my temporary folder, it'll reopen and just go back to exactly where I just left off. Okay. So now I have the part again. And let us just finish. Okay. We were talking about the whole wizard process. I'm not going to use that now. I actually am, but we have a different way of using this also. Remember I said we have something called drag and drop? Over here, I also have a whole wizard process, drag and drop. I can just take the drag to hole to that particular hole and let go. What's happening now, it's creating automatically 3 operations: the spot drill, the regular drill, and the tap drill for those operations. You can see, even if I were to open up just the tapping operation, you can see that the tool that I used was the proper tool. I'm going to use that same option for these tools, for these holes over here. Different tapped hole, 3 more operations. You see how quickly he did it? I'm going to open up my tapped hole, my last operation over here. If I go to the tool, it's a 3 millimeter M3 by 0.5. In other words, it recognizes whatever was done inside the SolidWorks whole wizard and puts all the information in and picks the proper tool needed for those operations. Okay. The same thing can be done for the counterbore holes. Okay. If I take drag to hole to the counterbore, it'll work on all the counterbore holes that were created with that hole wizard. And in particular case of a counterbore hole, it's using 5 operations, creating 5 operations. Why 5? Let's see. Let's just mark all of these over here. and run my simulation. Use Solid Verify. The first one was the spot drill that I needed. The second one was the drill that went all the way down. The third one, I'll start with slowly, was the drill opening up. Sorry, the end mill that's actually doing a circular helical profile into that hole for the counterbore. That'll go to the end. The next one is doing a little bit of a chamfer for the bottom hole, because it was a very small chamfer we like to put on. And the next one, oops, sorry, I forgot to mark that one. My mistake. The next one, using that same spot drill, and using the spot drill actually for putting a little bit of a chamfer on the tool itself also, on the hole itself. I'll run that to the end also. So all of this was done over here. Now, every single one of these, by the way, can also be edited. So if I don't like something that was done over here, I can just open up the operation. And the regular operation, just like any other type of operation, I can change tools, I can change levels, I can change technology type. Anything I want to do, I can change in here. Okay? These are regular operations that we have here. Okay. Any questions up until here?
So it's just again, Sydney.
Yes.
So what does it mean? The whole wizard process, does it mean that it's similar that you have a subroutine built already before inside here?
Yes. We have a default machining process. Okay. Machining process that's tied into the whole wizard process. Okay.
So it is that. So it's easy to use it first, any hole, because then you can just change the tool, or if you want to change the process inside, but you have a built process for this hole.
That's you talk back. I can do it for every single hole that was created using whole wizard process of SolidWorks. Okay. But let me just show you one more thing. You notice I dragged it to each one of these individually, right? Each one type individually. I'm going to delete what I did here. And yeah, those are suppressors. It's irrelevant. I have another option here called drag to surface. If I just drag this to the part anywhere to one of those surfaces facing my home position and then let go, it's actually scanning every single hole that's in that home position and creating the operations for every single one of those holes, instead of me doing it individually.
It's much faster, is what I meant. Okay, thank you.
Yes, I did this on purpose. I wanted to do this slowly. Remember how I first started off?
Yeah.
I first started off doing each hole individually without any kind of process, defining my spot drill, defining my drill, defining my tap. And here then I did with the whole wizard to the hole, and now I did it to the whole wizard to the entire surface, to the entire part.
So you can drag every operation and to copy it if you have another operation, like pocket to pocket, hole to hole,
right,
tab to tab, and just change the details inside.
Right, exactly.
Like to go to technology or whatever.
Right, exactly. And instead of creating operations individually, every single time you do something, you don't have to start from scratch every single time.
Yeah.
Okay. Now there's one more thing I'd like to do. Okay. Let me get rid of these suppressed operations. I really don't need them, as you saw. I'm going to mark all of them and just click on delete. Okay. Now that I've created all these operations, let's not deal about the slot right now. But now that I've created all the operations that you see over here, what I'd like to do is I'd like to break the edges, put a deburring operation for over here, for these edges. Okay? And if we look at the part, we have sharp edges over here, over here, over here. We even have over here. Okay? I don't want to touch any of the holes. Okay? So how do I do that? We have something here called Chamfer Recognition, which, by the way, I think next year I'm going to change the name of this from Chamfer Recognition to deburring recognition instead, because this is not the correct name for it. It's confusing. Anyway, I'm going to use Chamfer Recognition. When I create a geometry, I'm going to do several things. Remember, I said if I click on the part just the way it is right now, it's recognizing every single edge that's over there, including these edges over here. Now, I said I do not want to pick up the holes. Okay, because I already did that. Let me delete what I did over here, unselect. And we have here what they call a circular pocket diameter filter and filter fillet. I'm going to say that my minimum diameter is over here. Okay? Now when I click in that part, it's going to take everything that's larger than that diameter. Anything less, that diameter or less, it will not choose it. Okay. I'll accept this. By the way, you notice it says over here, I forgot my mistake. The reason why I picked every edge, because it says here solid body. If I wanted a particular face, I can say, okay, just give me a specific face, and then start picking faces. But right now, I want to do the entire part. I'm going to click on OK. But one other thing that's important to use over here also, something called 3D model protection. This will guarantee that my tool that I'm going to use, my chamfer tool that I'm going to use, will not touch the target. And why is that important? If I were to look at my geometries over here, you'll see that my edges go all the way up to this part over here, all the way up to here. I don't want it to go all the way up to there, my tool, because then it's going to gouge into this edge over here. Okay? If I put in 3D model protection, it'll protect my model itself. I can even say, how much do I want to offset from the model? Say 0.2 millimeters. Okay. The tool that I'd like to use, I'm going to add a chamfer mill. I'm going to leave it at a 10 millimeter chamfer mill. Okay, 90 degrees. Now, I know some people, I'm sure you've seen it also, that you'll find a lot of people that say, I'm going to take my spot drill and use that to use my chamfer. Everyone can do whatever. You're not going to stop anyone from really working whichever way they want. Okay, they can do that with that. They can use these kind of tools, whichever way people are used to working. It's not my job to teach people how to work. It's just my job to teach people how to use the program. And then they apply the technology to their best way. So basically, you can use either a spot drill or this mill. We're not limiting to what you can use. Okay. Okay, so I'm going to use this tool. Accept that. In my levels, what's important over here is how deep do I want my chamfer? What's the size of my chamfer? I want to put a 0.5 millimeter chamfer. Why? Because that's what it says on my. Actually, no, sorry. I want to put a 0.2 millimeter. 0.2. Break all edges, 0.2 millimeters. Okay? In my technology, I want to pay attention to this over here. Cutting diameter. You note, when I have my cutting diameter, we have our tool over here. It's showing what diameter of the tool do I want to use to cut with. Okay? So let's say I want to use the 2 millimeter diameter of the tool. You know what? No, I'm going to read it up 1.5 millimeter of the tool. Okay? I'm just going to do now save and calculate. What just happened here? Okay? Let me just double click on this for now. What happened here is it created a tool path for every single one of those edges. And let's actually take a look at the simulation. I'm going to double click over here again to reopen this. Run my simulation. Again, using Solid Verify. Let me run it quickly. You'll note what happened over here. It went in as far as it possibly go without gouging the part. Let me run it now a little slower so we can see what's happening. Now I'm going to zoom out. Okay. It's working on all of the edges. Go a little faster. Let me zoom into this area over here, and you can see exactly what happened over there. You will also note that these edges over here, it did not do. The reason for that, very simple. If I were to
Yeah,
do
but
this,
also to the step.
exactly.
If you see the step, yeah.
Exactly, because then it would, if we have our target protection, okay? So I can do several things. I can just change my tool. I'm going to go and use actually here a very small tool, just to show exactly what we can do over here. And the tool that I'm going to use a 3 millimeter chamfer mill. Okay? I mean, you guys know better what to use, but I'm just going to use it just now just to show what I'm doing over here. Okay? In my technology, I'm going to change this to 1 millimeter. Okay? Save and calculate. Did it do it over here this time? Still did not do it over here. Okay, because it's still too close. Okay, so let me enlarge at my cutting diameter so it goes further away from the wall to 1.3. Let's see if we have that now. Now it will cut over here. Okay? Why is that? Let me just bring this down over here a little. If I were to click on this edge over here, you can see that the length of that is 1 millimeter.
Yeah, you see the limitation. Yes.
Okay. So I'm working within my limitations. Okay. Now if I run my simulation on the entire part, you can see it did that as well. And not only that, these edges over here, it's actually closer because I'm using also a smaller tool. Okay, so that's one of the also really nice things about the chamfer recognitions, which is really a deburring operation. Okay, are there any questions? Okay, now this has been recorded. Next week, because over here in Israel it is Independence Day on Monday afternoon and Tuesday afternoon and all day Wednesday. We will not be learning next week. In 2 weeks, we will meet again. There's a few more things I'd like to pass over to you guys as well. Now, Isabella, are you on the line?
Yes, I am.
Okay. We have our meeting tomorrow, correct?
Correct.
Okay. Please add Emil Somech to that.
Okay, I will add him to him. No problem.
Okay.
I will do that now.
Okay. Thank you very much. Okay, everyone.
Thanks, Sidney.
Take care again, and we will see you again, or at least speak to you again in another 2 weeks. And again, you have this part. If you can, practice on it. Come back with questions. More than willing to answer any of your questions. Okay? All right.
Thank you very much, Sidney. Thank you
Thank you.
very much.
Thank you.
Thank you, Sidney.
Thank you. Thank you.
Thank you very much, sir.
Bye-bye, everybody.
Thank you. Bye.